Why is it difficult to detect the presence of an anti-neutrino during beta decay? Define the term decay constant of a radioactive nucleus and derive the expression for its mean life in terms of the decay constant. Okay. We'll see the first part of the question here, that is, why it is difficult to detect the presence of an anti-neutrino during beta decay? Because the penetrating power is too high. Because of the penetrating power is high, it is very difficult to detect the presence of an anti-neutrino during beta decay. Okay. Next, define the term decay constant of a radioactive nucleus. It do not interact with the matter. Any one decay constant is the reciprocal of the time duration in which the undecayed radioactive nuclei reduces to 1 by E times the nucleo present initially. Okay. And the expression we can write this one as tau is equal to total lifetime of all nuclei divided by total number of nuclei. Okay. Then we can write the same thing, that is tau is equal to total, that is in terms of integration, that is 0 to infinity, that is T into D into N divided by total number of nuclei, that is N naught. Then we can write this one like if I would substitute the values, then integration with the limit 0 to infinity, then T times N naught lambda epsilon to the power of minus lambda T times dt with respect to time divided by N naught. Okay, then which will give the result, that is lambda, it is constant with integration, then Te to the power of minus lambda T times with respect to the dt, where tau is equal to 1 by lambda. This is the final expression. State two distinguished features of nuclear force. Some of the features of nuclear force are, it's a short range force. Second one, the strongest force, attractive in nature, does not depend on charge. These are some of the important features of the nuclear force. Okay. Draw a plot showing the variation of potential energy of a pair of nucleus of a function of their separation. Mark the regions of the graph where the forces is attractive and where it is repulsive. Okay. Observe, this is the diagram. Okay. And this case, the potential energy it is on the y-axis and the R value it is in the x-axis. Okay. If you are going to take the R naught value is here, and if the R and the R naught value, if the R value is less than the R naught value, then it is repulsive. If R value is greater than R naught, then it is attractive. R is less than R naught, it is repulsive. R is greater than R naught, it is attractive.